Hi guys, so today is going to be a follow along for the probability and binomial distributions homework. So problem 1. Consider each distribution, determine if it is a valid probability distribution or not, and explain your answer. So first one here, x, so what we're doing here, a probability distribution, remember that the sum of all outcomes must equal 1. So we just add up all the p of x's here. 0.25 plus 0.6 plus 0.15, and that is equal to 1. So yes, the sum of the outcomes for the distribution is 1. Now we're going to look for the same thing here to see if the sum is 1, and we add up that in our calculator, we get a total of 1.05, and so no. This is not a probability distribution because the sum of the outcomes is greater than 1. And problem 2, USA Today reported that approximately, X equals the number of prisoners out of 5 parole who become repeat offenders, and their corresponding probabilities are shown in this table. Okay, so what is the probability that one or more of the 5 parolees will be repeat offenders? So the probability here is X is the number of prisoners, and this is their probability. So one or more includes 1. So 1, you add this all the way up to 5, and we have 0.369 plus 0.264 plus 0.088 plus 0.015 plus 0.001, and we get a total of 0.737. And find the probability that 2 or more of the 5 parolees will be repeat offenders. 2 or more is including 2, so 0.264, or we could just do actually the 0.737 minus the 1 here, since we are including 2 to 5 instead of 1 to 5. So 0.737 minus 0.369, we get a total of 0.368. Now, what I didn't talk about here was when we were solving A, which says that what is the probability that one or more of the 5 parolees will be repeat offenders? Why didn't we just subtract 1 minus 0.237? Well, if you add all of these probabilities up, the total is actually not equal to 1. So this is not a probability distribution. So C, find the probability that 2 or less of the 5 parolees will be repeat offenders. So 2 or less is including 2, and it goes all the way down to 0. So 0.237 plus 0.369 plus 0.264. We get a total of 0.87, and compute the mean number of repeat offenders out of 5. So basically what we're trying to do here is finding the expected value. In order to find that, we multiply x by p of x. So 0 times 0.237, 1 times 0.369, and 2 times 0.264, 3 times 0.088, and 4 times 0.015, and 5 times 0.001, and we get a total of 1.226. That is our expected value. And in order to find the standard deviation of the number of repeat offenders out of 5, we have to go use our calculator for this, and we go to stat, edit, and we fill in x as list 1 and p of x as list 2, and then we go to second distribution, or actually stat, calc, and we calculate one variable stats, and then we find the population standard deviation, and that value is 0.98. And the problem 3, a basketball player has a 60% chance of making each free throw. So we're also going to use our calculator here. So we're going to go to second distribution, go all the way down to binomial PDF. Now we're going to use binomial PDF because it's exactly 3 out of 6 throws. So the total number of trials is 6 free throws, and the probability is they give that 60% or 0.6, and the x value is basically the number of times you want that to occur, which is 3, and we get 0.27648. And what is the probability that the player makes at least 4 out of 10 free throws? So now we're not saying exactly, so that means we're going to use binomial PDF, CDF, which is below the PDF function. So we're saying at least 4 out of 10. So we're including 4, at least 4. 4 and up, 4 to 10. And our total number of trials is 10. And our probability, again, is 0.6. That hasn't changed. Except this time, we're not going to put 4 as the x value because we are including 4. And we're going to put 3 because that is the lowest number below the highest number below 4. And it's going to include 3, 2, 1, 0. So that we know the probability that the player makes at least 4 out of 10 free throws. So this represents, the value that we get is 0.0547, but we're going to do 1 minus that value because we want the value above 3210. And we get 0.945. Sorry. And problem 4, a class of 7 students. What is the probability that exactly 3 out of the students were born on a weekday, Monday through Friday? So again, we're going to use probably a calculator for all of these questions. And we're going to go to second distribution. Because it's exactly 3 students, we're going to use binomial PDF. And our total number of trials is the total number of students here, which is 7. And the probability in this case, we're talking about the probability of a student being born on a weekday out of the whole week. So there are 5 days in a week out of a total of 7, so it'd be 5 out of 7. The x value is the number of students we want to have this trait, which is 3. We hit enter and we get 0.085. What is the probability that more than 3 of the students were born on a weekday? So we're going to use the binomial CDF function for this because we are not talking about one exact value, and the total number of trials, it stays the same. It's 7, and the probability is the same because we're talking about weekdays again, so 5 out of 7. The x value here, though, is, since we're talking about more than 3, we're not going to include 3. So more than 3 is from 4 to 10. So since probability distributions go from left, decreasing, we are going to use we're going to use 3 as the x value because we are not including 3, and we are not including 3 and everything below it. So we get a value of 0.018, but this, remember, is the value that we're not going to include. So we're going to do 1 minus 0.108 to get the value above 0, 1, 2, 3, which is less than what we're trying to get. So we get 1 minus that equals 0.89. Problem 5, class of 6 students. What is the probability that exactly 2 of the students were born on a weekend? Again, exactly, we're going to use binomial PDF. The number of trials is the number of students, which is 6, the total number of students. And this time, we're saying, what's the probability that 2 of these students were born on a weekend? So weekend, they are 2 days of the week, and out of 2 out of 7 days. So we're going to do 2 sevenths. And the x value for this is 2, which is the number of students we want to have this trait. And we get a total of 0.319. What is the probability that less than 2 of the students were born on a weekend. So here we're going to use the binomial CDF since it's cumulative, includes more than one value, and our total number of trials stays the same, and our probability is the same, and our x value, let's see if that changes, we're talking about less than 2 of the students, so we're not including 2. So less than 2, if you think about it, we have 0 and 1 as a possibility. So since 1 includes 0, since we're going cumulative and it's going down, 1 and 0, when you put 1 as the x value, it includes 0. So we're going to put 1 as the x value, and we get a total of 0.45. For problem 6, a hotel has 4 elevators. One of the 4 is a freight elevator. While pressing the button, one of the elevators randomly services your floor. If you use the elevator 7 times, what is the probability that you use the freight elevator exactly 3 times? So this is a binomial PDF function. We're going to use that. And the total number of trials is 7. And the probability is the probability that you get a freight elevator. Since there are 4 and the freight elevator is one of them, we get 0.25, which is 1 out of 4. Our x value is 3. And we get a probability of 0.17. If you use the elevators 10 times, what is the probability that you use the freight elevator 3 to 6 times? So this is inclusive. And we're going to use the binomial CDF function. So first, the number of trials is 10, and the probability of freight elevator is 0.25. And we are seeing the 3 to 6 times, we are finding the probability that we use the freight elevator 3 to 6 times. So what we're going to do is we are going to find first the total number, which is 0 to 6 times, and we're going to put 6 as the x value. We get 0.99649, and in order to get rid of, because 0 to 6 includes 0, 1, and 2, we are going to get rid of that. So, sorry about that. So, in order to get rid of that, we need to subtract the values for 0, 1, and 2. And since the distribution includes, when you put a number as an accumulative function, it counts that number and down. The highest number here in 0, 1, and 2 is 2, so we're going to use the x value as 2, and we're going to subtract that from our previous value where we had an x value of 6, and this is going to be 0.47. 0.47. And this is the probability that we get the freight elevator 3 to 6 times inclusive. So that is all I have for today, and thank you so much for watching.